Aluminum cans fly off store shelves and end up in recycling bins at a rate you wouldn't believe. Across countless facilities worldwide, more than 120,000 of these cans are recycled each minute, fueling an endless loop that might just be one of the most efficient processes on the planet. But while this rapid-fire transformation seems straightforward, take an empty can, melt it down, and create a brand new one. There's a hidden world behind the conveyor belts. Ever wonder if all those cans you toss in the blue bin really find their way back onto the shelf? Or if the energy used to melt them down is actually worth the environmental payoff? This is where aluminum stands out from almost any other material you can name. It's infinitely recyclable, meaning it can be reprocessed again and again without losing quality. That simple fact helps keep aluminum at the center of modern consumer packaging. Still, the controversies surrounding recycling, especially for metals, have grown louder in recent years. Some skeptics say most of our well-intentioned recycling ends up in landfills anyway. Others insist that big corporations are simply greenwashing their images by advertising 100% recyclable packaging while ignoring the carbon footprints of their factories. Today, we'll peel back the layers of how the recycling industry processes these cans and dig into why so many rumors persist about the real impact of it all. Think about how often you crack open a soda during the day, or an energy drink, sparkling water, or juice in a sleek aluminum can. Multiply that by billions of people around the world, and you start seeing why factories are racing to keep pace with aluminum demand. We're talking about an industry that manufactures hundreds of billions of cans each year, and that's just the beverage sector. But the incredible scale of aluminum doesn't stop there. Cans aren't only for drinks. You'll find them used for canned foods, specialty packaging, and even personal care items. The versatility and low weight of aluminum mean it's cheaper to ship than heavy glass or steel containers. So, it's no wonder companies churn out these thin-walled metal cylinders at lightning speed. Unfortunately, that demand also generates enormous waste. Without recycling, we'd be drowning in a sea of empty cans. That's where modern recycling facilities step in, claiming they can turn mountains of discarded aluminum into fresh, shiny products in a matter of hours. Yet rumors abound that the surge of aluminum cans, especially in certain regions, overwhelms recycling centers. Some people suspect that whenever prices for scrap metal drop, facilities quietly divert a portion of aluminum to landfills rather than process it at a loss. It's a serious concern. After all, if recycling is supposed to help the environment, does it truly work when the market dips? Still, across many parts of the world, aluminum recycling rates are impressively high, somewhere around 75% and climbing in certain countries. Why so high? It turns out that repurposing aluminum saves over 90% of the energy needed to create brand new metal from bauxite ore. That economic benefit typically outweighs any dip in scrap metal prices, making aluminum a champion in the sustainability arena. But the story doesn't end with big numbers. Let's look closer at exactly how those 120,000 cans get sorted, shredded, and reforged every minute. Picture the inside of a typical recycling bin. Some soda cans, plastic bottles, maybe a greasy pizza box. It's easy to see how contamination starts. A single half-full coffee cup or leftover food can spoil a perfect batch of aluminum cans. In many locations, People are encouraged to rinse their recyclables, but not everyone does. This leads to sorting headaches for recycling centers. Once collection trucks arrive at sorting facilities, massive automated systems scan the incoming stream of materials. As the mixed recyclables move along conveyor belts, optical scanners, magnets, and even blasts of air help separate aluminum from glass, plastic, and paper. Most modern recycling plants rely on eddy current separators, a clever piece of machinery that uses magnetic fields to repel aluminum cans away from heavier metals. It's an impressive sight. Thousands of crushed cans whizzing along one belt, swiftly redirected off the main path by invisible forces. However, problems arise when items made of other materials sneak in. An aluminum foil sheet, for example, might pass through, but it lacks the thickness of a can and can jam machinery. Pieces of plastic or steel can get lodged in equipment or degrade the purity of the final molten aluminum. Some experts claim that up to 20% of a typical recycling haul is deemed contaminated and discarded outright. That leads to rumors of mass landfill dumping. Are we just funneling a big chunk of recyclables right back into the ground? Industry insiders push back, saying the majority of aluminum cans, especially those properly sorted, do make it through. And because there's a financial incentive, aluminum scrap is valuable. Recycling centers work hard to minimize what they toss. Either way, the sorting phase is one of the biggest hurdles. Once a batch of cans has been separated, it's onto a more dramatic stage, shredding and melting. After being sorted, the cans are fed into industrial shredders, equipped with sharp, rotating blades. In seconds, the flattened or crushed cans are torn into tiny pieces, a chaotic flurry of aluminum confetti. The purpose? To remove any last remnants of coatings, labels, or leftover liquids. Smaller pieces have a higher surface area, making it easier to burn off impurities in the furnace. Next, these shredded bits enter a decoating kiln. Here, intense heat, often surpassing 500 degrees Celsius, burns away paint, lacquer, or residues clinging to the aluminum. It's a necessary step because any contamination can degrade the final metal's quality. This phase sparks environmental concerns among some critics who worry about fumes from burning off the can's polymer coatings. Factories typically have filtration systems to capture and treat harmful emissions, but people living near big recycling facilities sometimes complain about air quality. Once stripped of coatings, the aluminum pieces move on to the heart of the operation, the furnace. Temperatures can climb beyond 700 degrees Celsius, causing the metal to become liquid in a matter of minutes. The molten pool glows bright, swirling with bits of dross, an oxide layer and other impurities that float to the surface. Skilled operators periodically skim off this dross. While it might look like worthless gray slag, some facilities can further process it to extract residual aluminum, ensuring minimal waste. This is also where rumors of corner cutting emerge. Some factories are accused of dumping contaminated slag, potentially harming the environment. Others have been praised for investing in technology to reprocess or safely contain furnace byproducts. In any case, once the aluminum has melted, it's effectively ready for its next life, provided it's poured into the right shape. The molten aluminum is then transferred to casting units, where it's poured into molds to form large blocks called ingots or billets. These can weigh several tons each. Aluminum in this form is stable and easier to transport to rolling mills. From there, the magic of turning a giant slab into an ultra-thin sheet begins. Rolling is a multi-stage process. The ingot is preheated to make it more malleable, then fed through enormous rollers that apply hundreds of tons of pressure. Each pass through the rollers reduces the thickness. The aluminum emerges longer and thinner each time, eventually forming huge coils that can be up to several feet wide and miles long if unrolled. Energy usage here is no joke. The rollers demand immense power, and the heating requires fuel. Skeptics point to this step when questioning the true greenness of aluminum recycling. But in defense of the industry, experts note that producing fresh aluminum from mined bauxite ore uses far more energy. By comparison, recycling is a net saver. In fact, it can reduce up to 95% of energy consumption compared to extracting virgin aluminum. That's why even in times of low market prices, it usually makes more financial sense for companies to keep recycling. As these giant coils cool, they become the raw material for new cans. Some will go to manufacturers that specifically shape them into the iconic cylindrical forms we all recognize. Others might end up in different products, from car parts to window frames. But let's follow the route of a beverage can and see how it's fashioned into something store-ready. Once the aluminum coils reach a can production line, they're fed into high-speed presses that stamp out the circular blanks. These discs are then drawn into cup shapes through a series of dies, each time getting taller and thinner walls. This is where precision matters. If the aluminum is too thin, the can might split. Too thick, and the manufacturer wastes material. Modern machinery can fine-tune the thickness to mere thousandths of an inch. What's astonishing is the pace. Thousands of cans can be shaped in a single minute on just one production line. Multiply that by dozens of lines in a massive factory, and it's easy to hit that astounding figure of 120,000 new cans per minute. But even after the basic can shape is formed, there's more to do, like trimming the edges, washing the interior, and baking on protective layers. Many beverage companies specify an interior coating to shield the drink from contact with metal, preventing flavor changes and corrosion. On the outside, branding is king. Cans are sent through printing stations that can apply multicolored designs at incredible speeds, giving each brand its signature look. After that, the top is attached, leaving only a small opening for filling. Typically, the beverage is added in a different facility or a separate section of the same plant. The final step is sealing the can with a lid and a pull tab. All of this ties into an interesting debate. Is it more eco-friendly for older factories to upgrade piece by piece? Or should they build brand new facilities with state-of-the-art energy-saving systems? Some environmentalists argue that constructing new plants demands massive resources, while others believe advanced technology reduces emissions in the long run. Regardless, the result remains the same: a continuous flow of new cans headed out to markets around the world. Meanwhile, on the consumer side, the cycle restarts the moment the can is emptied and tossed back into the bin, provided it's recycled correctly. Here's where the conversation gets thorny. We've walked through the process, but does it always work this smoothly? Multiple controversies surround aluminum recycling, greenwashing allegations. Some major brands proudly display 100% recyclable on their cans. Critics say it's a marketing ploy to distract from the overall environmental toll of mass production. True, aluminum is recyclable, but it also demands vast amounts of energy, even if significantly less than mining new metal. Another rumor suggests that whenever recycling centers can't handle an overload, or when the price of scrap metal dips, they'll quietly divert recyclables to landfills to cut losses. While it's difficult to confirm these practices on a large scale, anecdotes and whistleblower accounts persist. Consumer responsibility. A big chunk of recycling success hinges on individuals. If people don't rinse their cans or they toss random trash in the bin, contamination rates go up. Some places enforce strict clean recycling policies, fining residents for repeated mistakes. Critics call this blame shifting, insisting that corporations should simplify packaging instead. Energy footprint. Despite recycling being more efficient than mining raw aluminum, it's not zero impact. Huge electric furnaces, rolling mills, and transportation fleets still produce carbon emissions. The debate rages on whether the net benefit is as large as advertised or if industries inflate their environmental claims. A closer look at the economics of aluminum recycling reveals how it became so widespread. Energy conservation translates to cost savings. When you consider that creating virgin aluminum from ore requires mining, shipping the raw bauxite, refining it into alumina, and then smelting it into metal, it's clear why recycling is so appealing. Yet, as new environmental regulations roll in and energy prices fluctuate, recycling plants face pressure to modernize their operations. One emerging technology involves using renewable energy sources like solar or hydro to power electric furnaces. A handful of pilot facilities claim to have drastically reduced their carbon footprints this way, but skeptics say the overall energy mix for many factories remains heavily reliant on fossil fuels. The question becomes, will the global aluminum industry invest enough to transition to greener power, or will it opt for partial measures that look good on paper? Then there's the drive toward lightweighting. Manufacturers continuously experiment with thinner can walls to save material. If successful, this strategy reduces the aluminum required per can, meaning fewer resources extracted and less metal melted. But thinner cans risk structural integrity and may lead to more damage in transit. It's a balancing act between durability and material savings. We also see discussions about a circular economy approach, where manufacturers design products with the next recycling step in mind. For aluminum cans, this might look like simpler coatings that burn off cleanly or standardizing shapes for more efficient packing and transport. In fact, some experts envision a future where nearly 100% of aluminum packaging returns to factories, drastically cutting energy use compared to the status quo. Whether that vision becomes reality hinges on policy support, consumer behavior, and technological advances. So, how do we wrap our heads around the fact that over 120,000 aluminum cans are recycled every minute? On one hand, it's a testament to human ingenuity, a metal that can be melted and reshaped nearly forever, feeding a global demand for soda, sparkling water, and everything in between. On the other hand, it's a sign of just how deeply consumer culture relies on disposable packaging and the environmental responsibility that comes with it. As you've seen, the journey from crushed can to gleaming new aluminum coil is both complex and surprisingly efficient. From the careful sorting phase, where contamination can derail the process, to the roaring furnaces that reduce metal to a molten glow, every step has been honed to create a near continuous loop. Add in sophisticated casting, rolling, and reforming, and the average can might be back on store shelves in as little as 60 days after you toss it in the bin. But with great scale comes great scrutiny. Controversies swirl around whether these recycling efforts are truly enough, or if they serve as a convenient cover for corporations to keep pumping out single-use packaging. At the same time, skeptics question whether a portion of those 120,000 cans per minute might be lost to landfills when markets shift. The answers are rarely black and white. Aluminum recycling has proven benefits, especially compared to producing new metal, but it's no silver bullet for all environmental woes. What does the future hold? Maybe the adoption of renewable energy in smelting processes will slash emissions further. Perhaps new coatings or deposit schemes will improve sorting and reduce contamination, or we could see a push toward refillable containers that bypass the endless cycle altogether. The only certainty is that demand for aluminum shows no sign of slowing, and the race to recycle it faster and cleaner is on. Ultimately, aluminum's infinite recyclability might be one of our best hopes for reducing the enormous footprint of consumer packaging. The next time you crack open a cold drink, consider the extraordinary journey those empty cans take, shredded, melted, and reformed at astonishing speeds, just to find their way back into your hand a few weeks later. If nothing else, it's a testament to how resourceful humans can be when they choose to see value in what was once discarded. And it leaves us with a question that extends far beyond aluminum. How many other materials could we keep in circulation if we dedicated the same innovation and effort? It's a question worth asking, and it might just shape the future of recycling for generations to come.